Hi everybody, I hope everything is going well for you all. This is just an introductory lesson on quadratic equations and parabolas, and I'll just be covering the main things you'll be learning in this topic, and some key points and ideas that you'll need to know. This topic can be tricky, or it is quite tricky at first, but once you continue practicing, you'll get the hang of it, okay? But if you don't practice and persevere and study, it will be difficult for you. Now, there are a few dot points that I've quickly typed up that I want to cover in this session. And the first one is, what is a quadratic equation? And it's important to understand what we mean by a quadratic equation. And I'll just do a quick example. Now, if you have a look at all these equations, they are all quadratic equations. And the reason is the highest power of the variable x has to be 2. Okay, so we've got an x squared there, an x squared here, there's an x squared here. Now, with these ones here, we know there are brackets and a squared. That's indicating it will be a quadratic equation. And if you expand this, it will give you something like this, x squared and so on. This one down here, we can see a squared. And once again, if we expand this bracket and simplify, we will be left with a quadratic equation similar to the top one here. Okay, so that's how we know if an equation is quadratic. If I had an equation like this, y equals 2x plus 1, we know that this is not a quadratic equation. It is linear because the highest power of x or y is 1. Okay, but we mainly focus on the x when doing these topics. Usually the y power at this level is always 1. So the reason why we need to know if they're a quadratic equation is because if we try and draw this equation, it will give us what we call a parabola. So our next quick dot point is, what are parabolas? Okay, so the parabola is the graph of a quadratic equation. So if I was to, for example, draw this quadratic equation, and this is something you'll be learning, and by the end of this topic, you'll hopefully be able to do this. If you were to draw this using any method that you learned this year, it will give you what we call a parabola. So as a quick sketch, a parabola is something like that. You've got your y-axis, your x-axis, and your parabola is this shape here. They can be in all different locations and positions. Sometimes our parabolas, I'll do a different color, can be looking like this, so it's sort of upside down with a maximum turning point. They can also be shifted in any place really, okay? And these are all parabolas. So the equation of a parabola is called a quadratic equation. Don't ask me why they've got two different names for the graph and the equation. We know that a linear equation had a linear graph or a straight line, but that's just the way it is. Now, most importantly, where do we see parabolas in everyday life? Basically, parabolas are a natural thing that occurs in our lives. And with the help of gravity, parabolas, in this example here, so all the boys that like dirt bikes, if you did it in slow motion, you can see as this person is going up, he's also starting to fall down. And he reaches the highest point, which we call the turning point, and it forms a natural parabola. Parabolas can be wide or more narrow, depending on what type of example we're looking at. Now, this does not form a circle. It's really important. A circle is completely different to a parabola. Okay, let's look at a different example. So bouncing a ball, you can see when you bounce a ball in slow motion, it actually forms a parabola as it travels in the air, reaches the highest point, and then comes back down. So here we've got two parabolas. Bridges are really a good example of where parabolas are used in construction. So of course roller coasters are a lot of fun. So yes, throwing objects, and of course the peace sign, we sort of got a parabola in there. Okay, so you can see it's not half a circle. And I don't know what else I have here. I think I had, and of course our favorite thing, McDonald's. So the McDonald's sign is actually two parabolas, one there and one there joined together. So there you go. Now, our next slide point says, what are the main features we need to draw an accurate parabola? Okay, and this is really important because you'll be needing all these points to actually draw a parabola. Now, if you have a look at this example here, the red diagram here is the parabola, and parabolas can have various things. What every parabola must have is a turning point. So if you can see here, there's a turning point. In this case, it's a minimum turning point because we're going downwards. Every parabola must have that. Parabolas must also have a y-intercept. So here's the y-intercept. It's pointing, in this diagram here, it's telling us the y-intercept is 3, okay? And sometimes parabolas can have x-intercepts. Sometimes they may not have any, keep that in mind. But in this example, there are 2 different x-intercepts. This one here is at -1, and it cuts through also over here at +3. So remember, x-intercepts is when a line crosses over the x-intercept. Or in this case, it's a parabola with 2 different x-intercepts. The y-intercept, a parabola can only have one y-intercept and one turning point. The next important thing also is parabolas are symmetrical. So they have an axis of symmetry, okay? And that line means if I cut my parabola in half right through the middle, so cutting through the turning point, it will be exactly the same both sides. Now there's a lesson on the axis of symmetry, so you can watch that to help you make more sense of it. But these are the main features of a parabola, but keep in mind some parabolas may not have any x-intercepts, and we'll look at that later on. Next, what can quadratic equations tell us? Now, the more you become experienced with this, the more you'll be able to see when you're given a quadratic equation, you know exactly what to do, okay? Now, you start this process this year, and of course, next year, you'll become even more of an expert. Now, for example, here are 2 quadratic equations. In the first example, I can see that this equation here has been factorized, and this one here is showing me the x-intercepts. I can look at this and know exactly where the x-intercepts are, okay? Now you may not be able to do it at this stage, but that's what this quadratic equation is showing me. The second one here is showing me a few things, but the main one is it's showing me the turning point. I can look at this equation and know where the parabola's turning point is located. So if you remember, turning point means that bit there. I can look at this equation and it's telling me exactly where the turning point is. And this is something that you will be able to do later on, the more experienced you become with these equations. So remember, quadratic equations aren't just numbers and variables or in brackets and so on. They actually, depending on how they've been arranged or how you have arranged them, they're actually telling us something. And in these 2 examples, this one here is telling me the x-intercepts. The second one is actually showing me the turning point. And I could draw these with that information. The next dot point is asking us, can we use a table of values to draw a parabola? Absolutely. We can use a table of values to draw pretty much any graph, whether it's a linear graph, a quadratic, or parabola. The next one's to power 3, so a cubic graph. We can use a table of values to draw any of those graphs. And that is something that you need to know as well. And I think there's a chapter in your textbook that asks you to do that. But of course, we are also expected to know other ways of drawing a parabola and using those equations. Okay, but yes, you will have to learn how to use a table of values. Next important point is, what do we mean by solutions? Now, this is really important because if you remember in solving simultaneous equations, solutions meant what? So just to quickly recap, simultaneous equations were 2 linear equations that we had to work with. And if I, for example, drew a quick example on this graph here, if I had 2 linear equations and they cut through a certain point, that was the what? The solution. So we were finding one solution, okay? So it looks funny. That's what we meant by the solution. In this topic, in the topic of quadratic equations, solution means something completely different. Okay, so in this topic, in quadratic equations and parabolas, the solution or solutions means this, the x-intercepts. Okay, it's really important that you understand that. So for example, if I had a parabola on my graph just down here, there we go. This example here has two solutions. That's one x-intercept and that's the other x-intercept. And that's it. And to find the solutions, you basically have to be able to factorize. Okay, but before we look at that, the next point is, what are the three types of solutions? There are three different types of solutions we can have. So the first type of solution we can have is one where we just looked at this one. There was two x-intercepts. Okay, so two solutions is one option, or two x-intercepts. So two solutions. The second type of solution we can have is this one here. See how the parabola is just touching the x-axis? Okay, that one there we say is one solution. Okay, that's one solution or one x-intercept. It just touches the x-axis and just intercepts. Another way of looking at this one is two solutions or two x-intercepts that are exactly the same. But that might confuse you at this stage. So for now, it is just one solution. It just hits the x-axis at one point and keeps going. Okay? And the third option is basically no solutions, which means we can have a parabola where there are no x-intercepts. If you have a look at this one here, will this ever cut through the x-axis? You can see it's impossible. It'll keep going up and up and up to infinity, but it will never be able to reach the x-axis. There's a turning point, and that's the lowest point, the closest it gets to the x-axis, but then it starts going up. So unfortunately, with this example here, there are no x-intercepts, so no solutions. So they're the three types of solutions we can have, and the main three types of parabolas we can have. Now, this is where factorizing is extremely important. We've spent quite a bit of time practicing on how to factorize, and the purpose of factorizing is to find any x-intercepts, okay, so if there are any. Before factorizing, we must always analyze your quadratic equation and work out what method you need to use. Now, you may have already started with some of these methods, but these are the five main things to look out for. So the first one is, some equations may already be factorized. And I'll give you an example of that one. Now, these three quadratic equations are examples of where they are already factorized. So I can look at this and I can see what the x-intercepts of my parabola are. Okay, now the third one down here, remember, if you expand this, you'll get x squared plus x. So don't think it's not a quadratic equation. It is. There's the x squared. Even though we can't see it, if we expand it, there it is. So because if I had this equation here, to factorize it, we simply take out the x as a factor. Okay, so these are three examples where the equations have already been factorized. Okay, so I think I forgot to pause it before. Next one, some factors may be in brackets. So an example of that is, if you have a look at this quadratic equation, we can see the brackets here both show the same value, x minus 1 and x minus 1. So I can take them out as a factor. And if you remember, there's an invisible one here. So what we end up with is I take out my x minus 1 as a factor. And in the other bracket, I put in what's left. There's a 2x and plus 1. So 2x plus 1. And I've quickly factorized that. Okay, so with these types of equations, don't expand it and then try and factorize it. The quicker way is to take out the factor in the brackets if they're the same, and then put whatever else is in another bracket. Okay, so that's an example of that one. Sometimes you can take out x as a factor, and a lot of students, this is the easiest one out of all of them, and some students forget how to do it or don't realize what to do. That's why I'm pointing it out to you. Sometimes the simple step is take out x as a factor. So I want you to factorize the following example. So I want you to have a go and factorize this, and of course, before I forget to mention, we've got a y and an equal sign here, you can ignore them when factorizing. It's just saying y equals to make it an equation. Now, if you notice, once you factorize this isn't a quadratic equation, but all I've asked you to do is to factorize it. And what you should have done is, well, take out the x as a factor, and we end up with 2 plus 5, and of course, 2 plus 5 is 7. So we end up with 7x. Now, I should have given you an example that was a quadratic, so I'll do that now. All right, I want you to factorize this quadratic equation. And you do the exact same thing. So y equals, I can see I've got an x here and 2x is there. So take out the x as a factor, and we're left with 2 plus 5x. And that's it. Okay, so to factorize these ones, that's all you need to do. Now the next one is a method that you may have already learned. It's in a different chapter in your textbooks. I think it's chapter 8, but difference of perfect squares. Now this one can be a bit tricky at first, but it is pretty straightforward. There's a lesson on this, so please make sure you watch a lesson, especially if you need extra help. Now difference of perfect squares look something like this. This one here is an example of a difference of perfect squares, or DOPS. And this method is, well, first of all, you have to be able to identify if you can use it or not. And the basic rule is, if you have a squared, sorry, I just froze. So if you have a squared minus b squared, and we have that, okay? In this example, 4 can be written as 2 squared. Okay, so we've got a squared minus b squared, and then you'll be able to factorize it. But watch the lesson if you don't know how to do this yet. And the last type of equation to look out for are what we call trinomials. And remember, tri means 3. So as a quick example, if you had something like this, y equals x squared plus 6x plus 5. This is what we call a trinomial. It's a quadratic equation, and there are 3 different things. You've got the x squared, then you've got the 6x, and 5, the constant. So these ones are, I guess, more hard. They can become harder to factorize. The year 9 level, you don't have any numbers in front of the x squared, no coefficient, just 1. Whereas next year, you'll be factorizing things like this. For example, if you had a 5 in front of the x squared, you'll learn how to factorize something like that later on. And of course you can go ahead. But trinomials, there's a different method you need to use to factorize trinomials, and once again there's a lesson on that for you. So these are just some main points that you'll be covering when in this topic, and there are other lessons in the folder for you. Hopefully it helps you, and of course don't give up, keep practicing and work hard. All the best.